Alright, so this is for lesson 43. We're going to go over a couple of definitions to begin with. The first one is a chord. A chord is a line segment whose endpoints lie on a circle. Okay, so here's the endpoints. So this right here is a chord. Chord A, B. So a line segment whose endpoints lie on a circle. A secant of a circle is a line that intersects a circle at 2 points. It's a line that, so a line would be, this is a line segment because it has 2 endpoints, but a line would go on. So it actually crosses here and here, so let's call this C and D. So this would be a secant, line that intersects a circle at 2 points. That was Buddy, my dog. The tangent of a circle is the next one. So let me just name these right here. This is a secant. This is a chord. So C-O-R-D. And then the last one is a tangent. And a tangent is a line in the same plane as a circle that intersects at exactly 1 point, called the point of tangency. So this would be, a tangent. Okay, so tangent of a circle. Okay, and let's call this tangent, let's call this one, this is the point where it intersects the circle, let's call it E. Okay, so a tangent again is a line in the same plane as a circle that intersects at exactly 1 point on a circle, called the point of tangency. So this right here is the point of tangency. Alright, so let's go ahead to example 1, which is a circle. Let's see. I'll try to recreate it. Forgive my circles, please. So this is L, this is M, and over here is N. This is point P here, Q, S, and T, and R. Okay, so what are 3 radii and a diameter? 3 radii and a diameter. So we could say that 3 radii would be PL. So segment PL is radii. So I'm going to do radius. Okay, PL is a radii. What about PQ? PQ is a radii, and PN is also a radii. PN. Okay. If there was a line that went this way, then PM would also be a radii. The next question is identify 2 chords. 2 chords. So one chord could be, so this is a chord. One chord could be ML. Okay. Remember, and this is a line segment. So line segment, ML is a chord. Another chord is, believe it or not, NQ. I know it's also a diameter, but NQ is also a chord. Why? Because the definition of a chord is a line segment whose endpoints lie on a circle. So it didn't say it could not go through the middle. So NQ is a chord. And then part C says, name a tangent to the circle and identify the point of tangency. So a tangent would be ST, the line segment ST. So ST is a tangent, and point of tangency would be R. R is a point of tangency. Okay, so I hope that makes sense to all of you. Let's keep going. Okay, let's look at the theorem 43-1. Says if a diameter is perpendicular to a chord, then it bisects the chord. Then it bisects the chord and its areas. Okay, so if a diameter is perpendicular to a chord, then it bisects the chord and its arcs. So let's take a look at what that would look like. So if a diameter, so here's a point, here's a diameter. So if a diameter is perpendicular to a chord, so it doesn't matter which chord, it could be a chord going this way. Oh, I'm sorry, it's perpendicular, so the chord would have to be this way. Or if this diameter over here intersected this chord over here, or was perpendicular, then it's going to bisect the chord and its arcs. Okay, and its arcs. So it bisects the chord and its arcs. Theorem 43-2 just says pretty much the same thing. If a diameter bisects a chord, so if a diameter bisects a chord other than another diameter, then it is perpendicular to the chord. So if a diameter intersects a chord other than another diameter, then it is perpendicular to that chord. Now let's take a look at the two examples. So here's the first example, and here's the center. There's a chord over here. Okay, and let's call this right angle. This is 3, and this is x. Okay, so find the length of x. So based on theorem 43-1, because the diameter is perpendicular to this chord, then and it bisects the chord, x equals 3. Pretty easy, right? So let's just take a look at the same. Oh no, this is a different one. So 43b. Okay, so again, circle. And here's a chord. So here's P, point Q, and this is R. The center, we're going to call it O. Okay, so find O, R, P. O, R, P. Okay, so what is, I forgot to tell you that these two are congruent. So what is ORP? Okay, so angle ORP equals, so based on the theorem 43-2, because the diameter bisects the chord, and this chord is not a diameter, then it's perpendicular, which means both of these are right angles. So ORP is 90 degrees. Pretty easy, I hope. Alright, so let's look at C. The circle shown here has a diameter of 14 inches. So 14 inches. Okay, and what else? Chord AB, so this is A, and this is chord over here. This is B. This here is going to be point C, and this is point P up here. Alright, so now we know. Let's see. The circle shown has a diameter of 14 inches. Chord AB is 8 inches long. Okay, so this is 8 inches long. How far is AB from the center of the circle to the nearest hundredth of an inch? Okay, so how far is this center from the center? How far is this chord from the center of the circle to the nearest hundredth of an inch? Okay, so we have to see. So AP is a radius. Okay, so let's see, AP and CP. So C is 10